Given that sine 5 theta is equal to 5 sine theta minus 20 sine theta cubed plus 16 sine theta to the 5 for all real theta, it follows that the value of sine 72 degrees is one of these quantities. Okay. So how do I want to do this? My first instinct is to see what 72 times 5 is. Is that 360? 350 plus, yeah, okay, so that's 360. So I'm just going to write the identity for, I'm going to convert to radians right away because that's how I think. Minus 20 sine 2 pi over 5 cubed. I'm going to write it in the conventional notation rather than the way they give it in the question, but I understand why they would have wanted to write it the way they do. The power of 5. Okay, so this is the thing I want to solve for, right? I want to solve for sine of 2 pi over 5. The left-hand side is 0. Sine of 2 pi is 0. I know that sine of 2 pi over 5 is not 0, so I can cancel a power of that everywhere. Okay, and I'll simply, this is clearly now a quadratic expression. I'll let x be equal to sine squared of 2 pi over 5. So I have 16x squared minus 20x plus 5 is equal to 0. And quadratic formula, can I read off? I guess, I mean, the roots, the options given for the answers are pretty complicated looking, so I doubt I'm going to get a nice root of this in my head quickly at least. Let's just say x is equal to 20 plus or minus the square root of 400 minus 4 times 5 times 16 divided by 2 times 16. We have two roots here, so we'll have to think about which one we want. I'm not sure exactly where the additional root is coming from, but we'll probably, I'll draw a sinusoid and try and figure out which of these is not possible. It looks like they will in fact be two distinct values. Will one of them be negative? Well, let's just continue and see what we get here. Okay, so 20 plus or minus 400 minus 20 times 16. $20 times 16, that's 200 plus 20 times 6, so that's 360. So I have x is equal to 20 plus or minus 40 square root divided by 2 times 16. 20 plus or minus 2 root 10 divided by 2 times 16. Make sure I didn't mix something up, because 16x squared minus 20x plus 5 negative b plus or minus the square root of b squared minus 4 ac. Oh, no. Oh, yes. That's 320, not 360. Okay, good. 400 minus 320, that's root 80. And what should that turn into? Let's write this as 4 times 20, so that's 2 times root 20. Another divide by 4 again, so that becomes 4 times root 5 divided by 2 times 16. Let's divide out by 4. 5 plus or minus root 5 divided by 8. Okay, so now a lot of the expressions are starting to look the way they should. So sine of 2 pi over 5, if I look at a sinusoid, that's pi. 2 pi over 5 is about here. So this is the square root of this thing. I mean, I could take the negative square root because I said x is equal to this thing. So I have to take a square root of x to get the thing that I want. But of course, I'm taking the positive square root because of that. But why can I rule out either the plus or the minus? Where does that become a thing? This is an exact equation. That's true. Left-hand side is 0, so I can cross off 1 power from all those. No problem. My instinct is that it's going to be the positive one. Well, instinct, because this is, if I take 5 plus root 5, we get pretty close to 8, right? Root 5 is between 2 and 3. And, you know, I know that sine of this number should be close to 1 because sine of pi over 2 is 1. So, I mean, I'm certainly going to say that it's equal to 5 plus root 5 over 8, all under root sine, and that's option A. But where do we immediately rule out that option? Like, where is the other? What does the other root correspond to? The other root, 5 minus root 5 over 8. Root 5 is pretty close to 2. So that's about 3 over 8. It's in fact less than 3 over 8. Let's say less than 3 over 8. So if I take square roots, less than root 3 over 8, which is less than if I replace this with 4 over 8, it's less than 1 over root 2. And 1 over root 2, that's sine of 45 degrees. Right, so that's like there. So I know by that comparison, that's sine of pi over 4. Because of that, I know that sine of 2 pi over 5 has to be greater than this, so I know I'm taking the plus sign. But why are we eliminating the plus sign somewhere, or the negative root? At which point in this? I have to think about this more. I'm missing something. There must be like, maybe there's a simple step in the algebra somewhere that allows you to eliminate the minus sign. What does the other root even correspond to? So one root there and one root there. Oh, it's probably, yeah, this is probably sine of pi over 5. Because when I set that equal to 0, there's another value of theta which allows this to be 0, and that's sine of pi. So if I put pi here and pi over 5, pi over 5, pi over 5, and then continue with all the algebra, I've essentially solved for, at this point, the math doesn't know where actually here. The algebra doesn't know whether I'm solving for sine of 2 pi over 5 or sine of pi over 5. So, because, if I have sine squared of pi over 5 also satisfies this equation. So that's the root that is being taken out of that. That's that. Okay, cool. I'm happy now. I will check my answer, though, to make sure I don't have a mistake, and I'll let you know if I do. But that was a nice problem. Thanks for watching.